Good morning all. Today we are here to uh, present perform the experiment on three-phase induction motor, speed control of three-phase induction motor by varying the supply voltage and by varying the rotor resistance. So here also there are two set. One is by varying rotor resistance, another is by varying supply voltage. As you all can see, the aim of the experiment is speed control of three-phase slip ring induction motor by variation of rotor resistance and by varying supply voltage. Apparatus are: this is three-phase slip ring induction motor, 3.75 kW or 5 HP, 415 volt, 7 ampere is the rated ampere, and 1425 rpm is the rated speed. Then the three-phase variac, then or you may say this as three-phase thermostat or three-phase auto transformer. Then there is voltmeter having rating 0 to 600 volts. Then the ammeter 0 to 10 ampere, and we need tachometer to measure the speed. About circuit diagram, it is mentioned that here there is three-phase AC supply 440 volts having three terminal R, Y and B. After that, this three switches with the dotted line shows that the operation of all three switches is simultaneous operation. So it will operate at the same time, either on or either off. These are the three fuses. The input side winding, this is three-phase thermostat. So we first complete the series connection, then we go for the parallel one. So from first, it means supply is directly connected to the thermostat input terminal. From the output terminal, we directly connect in series with that to the R terminal. We connect here ammeter having rating 0 to 10 ampere. It is directly connected to the R terminal of your R, means red, yellow and blue. So it may be, you may consider this as A, B, and C. So this is your stator part and this is your rotor part. So initially we are supposed to connect the stator part. Then this one ammeter secondary side is connected to A, that is stator terminal of your induction motor, slip ring induction motor. This Y phase is directly connected to B phase of your stator winding of your induction motor, and C is directly connected to this B is directly connected to C portion. Talking about rotor, it is denoted as U, V and W. So U is directly connected to the slip rings. The first slip ring it is connected. This is variable three-phase rheostat. So if you want to change the position of rheostat, then by changing the position of resistance, your current will vary. According with that, your speed is supposed to vary. To do that, while you are changing the position of the rheostat, or you may say this as slip ring or the variable three-phase rheostat, when you try to change the position of this rheostat from 0.26 ohms to 12.5 ohms, this is the range. So when you try to change it, your speed is according with that, your speed is going to vary. Now these terminals R, Y, B shows that the input connection, the input supply which is present, three-phase input supply is present 4 on 5 volts. So it is R, Y, B terminals. This R, Y, B terminal is connected to the input of your thermostat. This is your input. After that, from the output, it is directly connected to ABC terminal. ABC is the terminal of your slip ring induction motor stator. So from here, first terminal, talking about this first terminal, it is connected to ammeter. From ammeter, it is connected to A. Now second terminal, it is directly connected to the B phase of rheostat, and third, that is from the auto transformer, it is directly connected to C. And this U, V, W, the rotor connections are directly connected here at the three-phase variable rotor resistance. So let me tell you the difference between the rotor resistance. In slip ring induction motor only you may find this rotor resistance. So to perform the experiment, we keep this as like this. So here it is, this is at maximum position. Here the positions are mentioned, maximum and minimum. This is maximum position, this is minimum position. These are the rotor resistances. So this is 3-phase, so that this is, consider this as first phase, this is second, and this is third. So this is at maximum position. When I am try to change it, the rotor resistance will change from maximum to minimum. So now to take the reading, here there is, now your rotor resistance is set at minimum position. The difference between slip ring and the squirrel cage induction motor is, if you want to change the speed according to the change in load, you always need to vary the rotor resistance. But in case of squirrel cage induction motor, it is not needed. The speed will automatically change. So initial case, your rotor resistance position should be at maximum position mentioned over here.
Safety precaution एक बताओ इसमें.
Here we draw the observation table. So we'll try to perform the experiment for this maximum portion only. Others are very similar to that. See, for example, if now I am going to show you the readings with respect to maximum position of the variable rotor resistance. If I want to set it at middle, so here I will set this as, this is point number 1, 2, 3, 4, like 8 terminals are there. So I will change the position like this. So fourth position I will try to set, that is middle position, and this is minimum. So now for the first set I am going to change the position up to maximum level. Now we are going to start the experiment. So this is the experiment. We have to on the supply. The supply is going to on. Then, as you all may know, that without supplying the voltage your induction motor cannot start. So this voltmeter present over here will give the actual rating. Now we are going to change the voltage. We are going to vary the voltage. So this voltage is supposed to vary. Now after reaching 50 volts, your motor is supposed to start. So this is how your motor is start. The motor will start and try to rotate till its rated speed when you supply the rated voltage. Now our rated position is, you are going to set it as 200 volts. So this is 200 volt and rotor resistance is at maximum position. So this is 200 volts and the rheostatic position is at maximum level. This is how we may able to check the RPM. So the RPM what we have is 1294. This is how we are going to check the RPM. So the RPM what we have is 1294 RPM at 200 volt and the maximum rotor resistance position. Similarly you may do same for this, for the others. Now I am going to change the speed. Now this is 240 volts. This ammeter is connected over here to measure the current, because no matter what happen your current should not cross beyond or go beyond 7 ampere. So the rotor speed is 1338 rpm, 1330 rpm. So here we note down as 1330 rpm. Now again we are going to vary the 3-phase variac position so that our voltage is supposed to vary. Now the reading what we want to set is 280 volts. So this is 280 volts, 280. The RPM what we have is 1362 RPM. So here it is for 280 volt at maximum rotor resistance position. Our RPM is, the motor RPM what we measured is 1362 RPM. Now again we change the rheostatic position. So we have the voltage now is 320 volts and the current is approx 2.5 ampere. Now here the RPM is 1384. This is the RPM what we have, 1384 RPM. Here by again wearing the rheostatic position, now our set voltage is 360 volts. So this is 360. The current what we have is 3.1 ampere. So the RPM at this level what we have is 1400 RPM. This is 1400 RPM. We have approx 1412 RPM, 14 RPM, 1400. So the RPM here is at 400 volt, RPM is 1414. Similarly, if you change the rheostatic position from maximum to minimum or middle as per your requirement, your readings are different. So first set can be easily done. Now just by changing the rheostatic position from minimum to middle and to maximum, so your readings are like, if you reach at this level, your work is to change the rheostatic position. So when you change the variable rheostatic position, rotor resistance position, then you have to start from here, go there. At this level you have to change again the variable rotor resistance position and will go from here to here by adjusting the voltage. Now the second set is of change in rotor resistance on induction motor speed. That is, you need to change the rotor resistance by keeping constant this particular voltage, that is supply voltage, constant. So we have already reached at 400 volts and the supply voltage is at 400 volt. Here it is mentioned. This is at minimum level, rotor resistance 0.26 ohms. So here the rotor resistance is maintained at minimum level. This is the chart what you have, 0.26 to 12.5 ohms. So here you keep this as minimum level. At this level the readings what we obtain is 1480 RPM. So the RPM what we have is 1480. Now we may change the rotor resistance position from minimum to next, that is second number. Total 8 rotor resistances are there. This is second number. After that we have to check the speed, because our voltage is constant at 400 volts, whereas we have to change the speed, and the change in speed what we have is 1472 RPM. So here it is 1472 RPM. Now we set the rotor resistance position, variable rotor resistance position at maximum level. We have already started from minimum. Now the next reading is for maximum level. Here you can see that the measured reading is 1416 RPM. So here it is 1416. Now you may keep this as constant and you just need to change the variable supply, that is voltage from the auto transformer, from 400 to 300, and you may start from here, end at here, by varying the rotor resistance from maximum to minimum by keeping voltage 350 volts constant. Simultaneously you are reaching over here. After reaching over here you just need to change the voltage from 350 to 300, and now your position is 0.26 ohms. So you just go from 0.26 to 12.5 ohms. So you have all the readings. Now to switch off, the procedure to switch off is 3-phase induction motor is, first of all you need to reduce down the voltage till 0 position, because we have already reached till its maximum level. Now here the position is 0, automatically the speed of the motor will stop. Now before leave the table, you just need to make sure that the main switch, this one, should be at off position, and you need to remove the connection before leaving the table. Now about the graph, your graph can be drawn in between two quantities. Quantities are in this case it is the applied voltage, that is 200 volt to 400 volt. With respect to that, you need to plot the graph between rotor resistance maximum, middle and the minimum. So on one of the axis it is three quantities are there, and on the x axis you will have this. These three are on the y axis, this is on the x axis. Similarly, this is on the x axis, and here the three quantities are on the y axis. So you need to plot the graph on the basis of these readings. Thank you.